Hi guys, in this tutorial I'm gonna solve question number 5, Mechanics 1 November 2021 exam. Small bead of mass 0.2 is attached to the end at the end P of the light rod PQ. This is the rod PQ. The bead is threaded onto a fixed vertical rough wire. So we have here a rough wire vertically, and the rod is PQ. The bead held in equilibrium. So it's better to show directions and the components of all the forces acting on the bead P. So by showing horizontally and vertically. Let us start to look at the forces which is acting on P. The first, its weight, which is acting vertically down, the mass given. So the weight will be mg, so 0.2 times g. What else? By looking at the rod PQ, makes an angle alpha where tan alpha is equal to 4/3 to get the exact values of alpha opposite over adjacent 4/3 to get the hypotenuse will be 5. So the exact value of sine alpha is 4/5 and cosine alpha is equal to 3/5. There is a thrust, it's given here. The thrust in the rod is T Newton. The thrust of the rod is acting in direction of P. This is the direction of the thrust. It's better to show that this force is out, like all the other forces. So if you extend direction of this force, it will be like this. This is T. Vertically opposite angle, so this alpha. So now if you resolve it, will be T cosine alpha and T sine alpha. If you act by a force left-hand side, so the normal reaction will be opposite. So the normal reaction will be in this direction. So now look at the forces acting on P. Its weight acting down. The thrust in the rod after extended to the other side makes an angle alpha. Resolve it horizontally and vertically, T cosine and T sine, normal reaction and weight which is acting down. What else? We have a frictional force, but where is its direction? The system in equilibrium. So you have to calculate the value which is acting up and the value which is acting down. So the frictional force with the lower one to make balance. It's given here in part A, find the magnitude and the direction of the frictional force acting on the bead when T is equal to 2.5. So now T is 2.5. T is 2.5. The forces acting up is 2.5 multiplied by cosine alpha, which is 3/5. You can calculate this value to know which is bigger, up or down, to know the direction of the friction force. 2.5 multiplied by 3/5. So the answer will be 1.5 Newton. And up is 0.2 times 9.8. So the answer will be 1.96. The forces acting down is more. So now it's clear that the frictional force will be up. The system now in equilibrium. So the forces acting up is equal forces acting down, which is F of y is equal to 0. So you can find the frictional force, which is the difference in between. If you write frictional force plus the force acting up, which is 1.5, is equal to the forces acting down, which is 0.2 times G. So you can now find the value of the frictional force, which is 0.2 times 9.8 minus 1.5. So the answer will be 0.46 Newton, 0.46 Newton. This is part A. For part B, the coefficient of friction between the bead and the wire is mu, given that the greatest possible value of T is 6.15. So we'll repeat again this part for resolving the forces, again horizontally and vertically, because the direction of the friction force may be changed now, because the value up will be more. By the same way, we'll extend the thrust of the rod, will be like this. And this value now is 6.125. 6.125, same angle alpha. So start to resolve it vertically and horizontally will be 6.125 cosine alpha and 6.125 sine alpha. The weight, which is acting vertically down, will be 0.2 G. If you calculate now the value up, 6.125 multiplied by cosine, which is 3/5. So 6.125 multiplied by 3/5. So this value 3.675 and 0.2 times 9.8. So this value found before, it's 1.96. The forces acting up is more than the forces acting down. So now direction of the frictional force is changed to be down. The system in equilibrium, if we act by action to the left-hand side, so there is normal reaction for opposite side. The system in equilibrium, when it's about to move, so f of x is 0, f of y 0. So all the forces acting to the right side is equal forces acting to the left side. So R is equal 6.125 multiplied by sine alpha, which is 4/5. And all the forces acting up is equal forces acting down. So frictional force plus 0.2 G is equal 6.125 cosine alpha. From the first equation, you can calculate the value of R, which is 6.125 multiplied by 4/5. So this value is 4.9. And from the second equation, you can find the value of the frictional force, 6.125 multiplied by cosine alpha, which is 3/5, and move to the other side to be minus 0.2 times 9.8. So the value of the frictional force is 1.715. System in limiting equilibrium, so the frictional force is equal to mu R, or you can write directly mu R is the ratio between the friction force and the normal reaction. The friction force 1.715 and the normal reaction, which is 4.9. So the value of mu 1.715 divided by 4.9. So the final answer is 0.35. That's it. Thank you.